Hello, everyone. Welcome to this video where we're going to talk about how we can use static code analysis to dramatically improve the quality of our code. I'm going to show the phases in which that happens, the phases of the process in which we can use static code analysis to start to gain visibility and improving the quality of the code. And it's going to be a very heavy session in terms of demos. So it's pretty much just demos. But before we get to that, just a quick intro. My name is Anderson Rangel. I am the solutions engineer for Redgate here in the APAC region. And what we are going to talk about today is where does static code analysis fit into our development lifecycle journey in our processes. So what we have here is developers making changes to databases, committing those changes into source control, where we are going to trigger the flow of our pipeline via our continuous integration and the deployment of those changes until finally we reach production and we can see and we can monitor, we can track the impact of those changes as well as BAU activities. And then from that point onwards, we recycle that journey by provisioning databases in an effective way. That's the Redgate journey at the highest possible level. So where does static code analysis fit into this picture, into this journey? So everything starts at development level. We are really dramatically or completely shifting left this technical debt prevention. So how can we identify as early as possible that there is something potentially wrong with what I am writing? And the earliest that we can do that assessment is at development time, as I am writing the code. And I'm going to demonstrate how that looks like. So if I chose to, or I didn't notice that there was something wrong with my code, and even though that was highlighted to me, I missed it, we will then commit that code into source control. But during continuous integration, we will be able to pick up those and break a build. If we choose to, we can break a build if there is some inconsistency with our code. If I haven't configured my build to break upon facing some of those obstacles or inconsistencies, I'll call it, during release management, we'll also have the ability to surface those inconsistencies. And even then, if I have deployed those changes to production using SQL Monitor, we will also be able to identify code that is falling under those best practices of performance, of use of deprecated issues, an array of categories and a multitude of rules. Will be scanning your code in order to provide you with that assessment. So throughout the demonstration, I'll show how our product, static code analysis, can be pinned into those phases of the life cycle in order to deliver that ultimate desire, which is quality code, code that doesn't smell. So let's see how that actually looks like. When you install your tool belt on your development machine or on the machines of your developers, depending on the role that you have in your organization, what that allows is for a tool to be installed in your preferred if you prefer to use SSMS IDE, the word escapes me, sorry. So if you prefer to use SSMS as your IDE or Visual Studio, it doesn't matter. I prefer SSMS, so I'll demonstrate on SSMS. So when you do that, you're going to have this product called SQL Prompt, which is amazing. If you write SQL, if your business writes SQL, have a look at SQL Prompt. Just it's free trials, full capability trials, and my take here. This is not a SQL Prompt video, but I can't help myself. The way that I see it is, if anyone asks me, do you want to write code 40% faster in a standardized way, where it's being protected and it's going to guarantee that you deliver better quality code? The answer is always going to be yes. So if you don't know SQL Prompt and you want to have a peek, go on. You enjoy it, I guarantee. But what I wanted to show is that we have embedded in SQL Prompt this ability, this component called code analysis, right? So if you want to have a look at what those rules are, we can expand that. We can click on that icon, and we'll be able to see all of the different types of categories of rules. So best practices rules, deprecated syntaxes, execution rules, performance rules. So it's nearly 100 rules that we scrutinize your code in order to find anything that is out of context. So also relevance if you have Oracle in your an Oracle platform in your environment, but fundamentally those are the categories of rules. If I want to find out a little bit more, I can just click on it and read through why we are saying that is a potentially a issue or a constraint to your environment. So one really cool thing that we can start doing it, if you don't know how healthy or unhealthy your code base is, so what we can do is run the code analysis against your database. So I'm going to generate the script for the database using SQL Prompt. You can use SQL Compare, apologies. I am going to use SQL Compare. Ow, that was bad. So I'm going to use SQL Compare here at the top. You could have used different tooling, but SQL Compare, it's my favorite, so I'll use that. And here I'm comparing my production database against an empty database. And out of that comparison, what we will have is all the objects, right? So I'll have a script with all the objects. And all I'm going to do after that is I'm going to copy that script, and I am going to, did I just execute it? Dear me, Anderson did it again. So I'll create another one just to show how easy it is. I'll create another empty database. I'll refer to that now. I'm going to run the comparison, and this time I'm not going to deploy. I just want to see the script. So the comparison is taking place. The cool thing about using Compare for that is that, let me just not get distracted here. This is what I wanted to have done. The cool thing about using Compare is that I can filter out certain objects if I choose to, and I can define the behavior of the comparison if I want to as well. So since that is not the point of this demonstration, and all I wanted was the actual script that I can use to recreate my whole database, I'm going to use that to, I'm going to use code analysis to highlight any potential issues with my code. So that's exactly what I'm going to do. And what it shows here is that it found 77 potential issues with my code. And when I have a look, I can see that I have all those subcategories there. And if I wanted to, one thing that strikes my eyes immediately is the fact that I have something in my code that is using an asterisk, some select statement with an asterisk. So I can double click that, and that will take me to where that is. We'll place the cursor exactly where it is. And it's even giving me a hint here. Because I have SQL Prompt, if I press tab, it will expand that wildcard. So I'll have all my, I have all my columns available. if I wanted to as well, if I want to get more clarity, I could just click on this little icon here, and it will tell me, well, it will ask if I want SQL Prompt to fix the problem for me, or I can actually have a look at the issue, why that is an issue. I can disable this rule if I want to, or I can go into that online documentation that we've just been. So up to us. So we are being surrounded now with options and of what to do in terms of deciding the best plan of action to address this issue. So for me here, I would definitely expand this wildcard. We can see here as well, and this squiggly line, this green squiggly line, it just telling me that there is something here that SQL code guards via our code analysis had identified. So here there is no schema definition here. I'm not full qualifying that object name. So if I do so, we'll be able to see that that goes. There is no begin and end on the body of this proc, so I can definitely address that as well. I will just surround that with begin and end, and that will go as well, hopefully. Sorry, there you go. So now that will go as well. What else is going on? Oh, there is already an object name. Okay, cool, because I am using, it's just that I'm pointing against a database that already has that data. So I'm going to point against that empty database that we just created, and that's not going to be a problem there. So when I refresh that, we should see that that number will drop. So now I have addressed some of the issues. We're not, I'm just showing how to use the suggestions and then go back and develop our code. You wouldn't do it to a baseline script. That's not what I'm suggesting. What I'm suggesting is that we then refactor our code so it removes those inconsistencies. And the list goes on. If I want to, for example, I'm using money here. That's a bit debatable, but we might want to use decimal data types there. It's up to you to decide. So if you find that, I understand, thanks SQL Prompt for letting me know why I shouldn't be using money data type. So I just want to disable that rule. That's fine as well. So when you refresh, that's not going to be a point of observation anymore. It's entirely up to us to determine what it is that we want to address. So that is just a high-level view. Obviously, I would not stop there. I would try to find everything that requires attention and address that by making changes to those objects. But like I've mentioned, this overview was just to show the power or the range or the extent in which SQL Prompt, alongside its static code analysis capabilities, can help us as developers and DBAs as well to identify potential issues with our code. So what I want to demonstrate next is, like I've mentioned on that diagram, how do I shift left the identification of those issues or potential issues as I am developing code. Then I'm going to make a change, deploy that change, and we're going to see how we can identify that as well. So for that, I'm going to use another one of our amazing products called SQL Change Automation. I have a project here for my confidential DB database, and all I'm going to do is to actually make some changes. So I'm going to go into my development database. I am using a shared dev there. We can if you are using shared development databases and you want to move away from that, I can reach out, and I'm more than happy to show how easy it is to completely demystify that the use of shared development databases are an optimal option. So, but nevertheless, all I want to do is make some changes into these shared databases, some really inconsistent changes. So I'm going to create a procedure. I'm going to give that a name, which is not going to be fully qualified. I'm actually going to, well, let me just remove this begin and end. I'm going to create a join statement here that, let me remove that as well. So GM customer, let's join that with credit card type. Oh, and this is SQL Prompt, by the way. This efficiency, SQL Prompt is an efficiency tool, as well as a tool that will protect your code. But it really helps to have a complete understanding about the structure, the underlying structure in which I'm developing on. So here it tells me what are the keys that I can use or should use to effectuate this join. So how many times have we lost going back into the structure, trying to find which one is the primary key, which one is the foreign key. I can then format the code so it looks a bit neater, and I can see that I have green squiggly lines everywhere. And I'm going to choose to leave it that way, right? So intentionally. Cool. So I'm going to execute this. I made this new proc and it smells. So there is a parameter that it's declared but not used. I do have that asterisk in there. I'm not aliasing the table. And yeah, and it's bad. So great that is bad in this case. So what I'm going to do is I'm going to use SQL Change Automation to identify the changes that I've made. So it's going to pick up this new procedure. And I am going to generate this migration. Fantastic. And once that is done, I'm just going to commit this code into source control. Straightforward, simple object change. So created smelly code proc. There you go. I'm going to push that code into my remote repo. And when I go there, I'm using Azure DevOps. Just for this demonstration, I could be using any orchestration system. And what I want to see is if that change have made, there you go, it has the creation of that smelly proc has reached my repository, which means that it should have started a CI process. I will pause the video because we're not interested in waiting for the CI and CD process to take place. So I'll pause it and we'll blink and I'll be back with the results. Awesome. So in a blink, the build process have finalized. We can have a look at what I have defined into this build process. We'll be able to see that I have validated my project successfully, meaning that the code, although it smells, it builds. So I can, it compiles, it's deployable. All dependencies have been met. And what I've intentionally left out, just so we can progress down the pipeline, is that I'm not breaking the build if I have smelly code. What I am doing here is introducing another layer of granularity in which we can control the quality of our code. And that is by implementing, running tests against the code base. So when you install the SQL tool belt in your machine, another product that you will have access to is SQL Tests. And SQL Tests uses the SQL framework to allow us to create the tests, but other than having to do that via diving into the database and figuring out all these different store procedures, which is fundamentally what those tests are, we have this nice UI where we can manage, control, and have visibility of our tests against not just the one database, but across many databases. So as a developer, before I even commit my code, I could have come here and run those tests against my database. So these tests, this set of tests are not the same set of tests that code analysis run. This is more around your organization probably have some do's and don'ts. What we want to achieve with this is a way of programmatically validate if your code falls within those thresholds, within those borders, right? And also it provides code coverage. It also makes sure that we are making sure that we are protecting our code as much as possible. The way that I see it is that you would not hire a application developer that said, "Look, I don't do unit testing. Like I don't write code coverage." So, but we do that but the database space allows for that. And the more we shift away from that mentality, I think the better we will be as an industry. So what we're doing is we're running these tests during CI. So here, 30 of my tests have ran successfully. Again, I don't want to break the view because I want to see things going all the way through. And the change that I've made, that proc that I've created, doesn't fall under any of those tests criteria. So when I go into releases, we'll see that I have already deployed that new proc to integration or UAT. What I will do in production here, the earlier shift that left, so if I was doing this in integration, if I had a gate here where I would analyze the same reports that I will now in production, the earlier I do that, the better. So here I can see, yep, it's a new proc that is going to be added, but there are 6 issues with that code. So here I can see that there is a parameter that I declared, but I haven't used. There is I'm not using aliases for the table sources, schema names, not specified, that's objects definition, procedures without beginning and end, and the dreadful asterisk on the select statement. So when I go into the script itself, I can actually visualize what it is that I'm deploying, and I can see where all of those issues are. So I can really easily identify where they are. And when I click on it, it will take me back to the analysis tab where I can choose now as a DBA or as a senior developer or someone that has the authority to approve or reject a deployment. Now it's up to me to say, all right, resume or approve or reject. Don't go any. I would definitely reject this guy. I just want to show, it's not the purpose of today, but I just want to show in UAT, for example, that proc has been successfully deployed. So it's not a demonstration on our flow or in our ability to deploy code. It's a demonstration in how, in our ability to identify potential issues with our code in all phases of the development life cycle. And the last piece of that puzzle, the last bit, is that even if I had deployed that to production, I still have ways of finding out where those problems are. So I'm going to connect to my I'm using SQL Monitor now, which is another product that you will have available in your SQL tool belt. I can go into the instance that I've made the deployments to. I'm just going to change the view here so we can see that a little bit better. And what these options here are, what these annotations here mean is that these are the moments in which I have made changes, right? So a really cool thing is that when I make deployments, I can see that on my timeline. So if my workload is going like this, and then all of a sudden it does that, then I know I can associate the outcome with the event. And that is really, really cool. I can even click on it and it will take me to the actual deployment where and when that was made. I can follow the breadcrumbs there, and I can go all the way back to who made the change and what is that change. So you can close that loop that way. Cool. But what I really wanted to show is that, in fact, apologies. In fact, instead of using my local environment, which is very boring, very uneventful, I'm going to use a different scenario just because it has more activity there. And what I want to find is some query that has some issues with it that will allow us to have a better look in here, a better look. I'm just going to move into this area of activity there. There you go. I'm going to move and see what queries ran at that period of time. And hopefully in one of these queries, we have some bad code written. So I think a distinct, there you go. So over here, we can see that SQL Monitor is telling us that we identified 3 issues with the query. So when I click on it, it will feel familiar because we are using static code analysis. And there you go. Another select statement with an asterisk. And just like before, I can expand, get more information. I can go into the online documentation. But the point here is that the same rationale that we are using to identify code as early as possible, we keep that consistency all the way through the life cycle, like I've mentioned a couple of times. So that was the demo. So a quick recap. We can identify, and we should be identifying technical debt, right? Before we create it, right? So let's not introduce to source control and through production eventually code that it's not in the shape that it should be. And the earlier we identify that, the more we shift that identification left, the cheaper and the less impactful that problem will be. If we miss that, we still can pick it up in continuous integration where we're going to build the code and we're going to run tests against that code, as well as having the ability to fail a build if one or some of the rules exist in that code. If we miss that, we can still present you with a report during release management that will allow you to see what the issues with your code are. And then you will have a decision to progress those changes or reject those changes, telling the dev to stop putting asterisks on the select statements. And even if you deploy, even after you deploy, we still have the ability to track where that inconsistency is. So what is the problem with my code? SQL Monitor will definitely help you in that space. So hope that has been somehow informative. If you have any questions, please reach out. It will be my pleasure to help you in this journey. So take care.